Have you ever wondered what reality truly is at its most fundamental level? We navigate through life with a certain understanding of the world around us. But what if I told you there's more than meets the eye? Quantum mechanics, a fascinating field of study, challenges our very perception of reality. It delves into the microscopic world, probing into the heart of matter itself. Quantum mechanics, a field of study that defies our everyday intuition, offers us a glimpse into the fundamental nature of reality. At the heart of quantum mechanics lies a single, powerful equation. Now let's dive into the deep end and discover the Schrödinger equation, the cornerstone of quantum mechanics. Picture this equation as the DNA of a subatomic particle, carrying all the necessary information about it. It's like a secret code, and once we decipher it, we can predict the behavior of particles with uncanny precision. The Schrödinger equation is made up of three vital components. First, we have the wave function. Think of the wave function as a map. This map doesn't show mountains or rivers, but rather the probabilities of finding a particle in different locations at any given time. It's a bit like predicting the whereabouts of a particularly elusive cat that loves to wander. Next, we have the Hamiltonian operator. Now, this isn't some obscure musical instrument. In our equation, the Hamiltonian operator acts like a magnifying glass, focusing on the energy of our particle. This operator takes into account both the kinetic energy, which is the energy of movement, and the potential energy, which is the energy of position or arrangement. It's like considering both the speed of a car and the steepness of the hill it's about to climb. Lastly, we have the energy eigenvalues. These are the possible outcomes when we measure the energy of our particle. You can think of these as the different speeds that our metaphorical car could be going when we check the speedometer. Now, I know this might seem a bit overwhelming, but don't worry. The beauty of the Schrödinger equation lies in its ability to predict the unpredictable, to give us a glimpse into the strange and wonderful world of the very small. So remember, while it might look like a jumble of symbols and numbers, each part of the Schrödinger equation has its own unique role. Together, they form a powerful tool that allows us to explore the quantum realm. This equation, while seemingly complex, encapsulates the fundamental principles of quantum mechanics. Quantum mechanics, as described by the Schrödinger equation, gives us a radically different view of reality. If the universe were a grand orchestra, the Schrödinger equation would be the conductor, directing the symphony of particles and waves that make up our reality. This equation, at its core, gives rise to two key principles of quantum mechanics: wave-particle duality and superposition. Let's start with wave-particle duality. Imagine you're at the beach, watching the waves roll in. Now imagine that each wave is also a particle, a single grain of sand. It sounds strange, right? But that's the essence of wave-particle duality. Every particle, from the electrons in your body to the photons from the sun, behaves both as a particle and a wave. This idea shatters our conventional understanding of reality, where we think of waves as continuous and particles as discrete. Now let's move on to superposition. Picture a spinning coin. While it's in the air, it's neither heads nor tails. It's both at the same time. This is a bit like superposition, where quantum particles can exist in multiple states simultaneously. An electron, for instance, can be in two places at once. Yes, you heard that correctly. It's only when we measure or observe these particles that they collapse into one state or position. These principles might seem bizarre, even outlandish, but they are the backbone of the quantum world, a world that operates on a different set of rules. Here, uncertainty is the norm, and what we perceive as solid reality is, in fact, a dance of particles and waves, constantly shifting and changing. So, next time you look up at the stars or down at the sand beneath your feet, remember this. Beneath the surface of our everyday reality lies a quantum world, a world that defies our understanding of space, time, and matter. In the quantum world, reality is a lot stranger and more fascinating than we could ever imagine. Quantum mechanics may seem abstract and far removed from our daily lives, but its implications are profound. From the microchips in our gadgets to the questions that philosophers grapple with, the influence of quantum mechanics is ubiquitous. It has reshaped our understanding of reality, nudging us to reevaluate our place in the cosmos. So the next time you gaze at the stars or use your smartphone, remember, you're experiencing the magic of quantum mechanics.